algebra students. Mr. Lawrence here, and I know some of you are still struggling with these fraction type problems. I'm putting together a video to help you out. Look, you've got to understand, fractions are no big deal. Come on in, I'll work with you on them. Okay, I'll show you how to handle them. They're really simple. Now, I know you don't have a lot of experience with them, but if you keep avoiding them and keep saying you don't know how to do it, you're never going to learn. Well, let's take a look at how I handle these examples. And I seem to be having a problem with my airliner. There we go. Okay, let's take a look at problem number 1. All right, I've got fractions on both sides of the equation that's bothering me. I know a fraction implies division. I can use multiplication to get rid of the fraction. The only problem is I can't just multiply the fraction because I'm in the middle of an equation. Remember, an equation is kind of like a seesaw, okay? And it's balanced when I start. If I do something to one side, say like multiply by 2, then I have to multiply by 2 on the other side, otherwise the seesaw becomes out of balance. So I'm going to multiply both sides of the equation by some number. What number? Well, whatever number will get rid of my fractions for me. Now, really that's a misnomer. I don't want to use whatever number. I mean, I can think of a lot of numbers that will get rid of these fractions, but I want to use the smallest number that will do that. And so what I'm going to do is I'm going to look at the denominators. I have a 2 and I have a 5. I'm going to think to myself, what's the smallest number that both 2 and 5 divide into? Well, I can count by the larger denominator until I get one that the smaller denominator will divide into. So I go 5, 10, stop! Yeah, 10 is the number I want to multiply by. So I'm going to multiply by 10, okay? And over here I'll also multiply by 10. And remember, this is a distribution situation. I have to multiply the entire side by 10. All right, so my first problem becomes 10 over 1 times 1 over 2. Now look, all this problem says is half of 10. You all know half of 10 is 5, but let's learn why. Let's not be content with just being able to do it. Let's figure out why. Now the second part of the problem is going to be 10 times negative 4. Okay, oops, do I have an extra negative in there? Sorry, let me do it this way so I don't get confused. I've got a negative 4 times 10. There we go. Okay, and then on the right-hand side, I'm going to have 10 over 1 times 1/5 x plus 2 times 10. Okay, well, let's go. So, right here, 10 over 1, we know it's going to be 5. Well, why? Because can't 10 be written as 2 times 5? And isn't 2 divided by 2 1? Don't they cancel each other out? 5 times 1 times x is 5x. This is simple, becomes minus 40. Okay, and this part, remember 10 can be written as 2 times 5. 5 divided by 5 is 1. 2 times 1 times x is 2x. 2 times 10, 20. All right, so now I've got variables on both sides. I like to get rid of the smaller of the x coefficients first, and then I'll have 3x minus 40 equals 20, right? Okay, now it's just a two-step equation. I'm going to add 40 to both sides. 3x is going to equal 60. And I'm going to divide by 3, and x is going to equal 20. And there you go. All right, problem number 2. Same idea. I'm going to multiply both sides by a number that will get rid of both my denominators. Well, if you can't see it, count by the larger denominator. 4, 8, 12. Stop. It looks like 12 is the number That will get rid of both. And I'll distribute. And then I'll multiply by 12 over here. And so this left-hand problem is going to be 12 over 1 times 2x over 3 plus 12 times 1, and then 12 over 1 times x over 4 minus 2 over 1. Oh, I don't need it over 1. They're neither are fractions. I'll keep it simple. Minus 2 times 12. All right, so let's see what happens here. Hey, 12 thirds, isn't that the same as 4 over 1? And 4 times 2 is 8, times x is 8x. This is just 12. This is 12 fourths, which is going to end up being 3 over 1. 3 times x is just 3x. And this is minus 24. Again, I've got x's on both sides. I'll take away the smaller coefficient of x. The x term with the smaller coefficient. I'll get 5x plus 12, and that's going to equal negative 24. I'll subtract 12, and then 5x is going to equal negative 36. And I'll divide by 5, divide by 5. X is going to equal negative 5 goes into 36 7 times. It's 1 short. Negative 7 and 1/5. Shouldn't be running to a calculator on these. They're too easy. You could have left negative 36 fifths as your answer. I was figuring that that might not make sense to you, so I went ahead and converted to a mixed number. But this is an acceptable answer in my classroom. Okay? This one probably makes more sense, so I used it. There's nothing wrong with this as an answer. All right, here we go. Problem number 3. I'm going to distribute. And watch what's going to happen here. I'm going to have 8. Negative a half times 2x is going to be, some of you are probably wondering why that's negative a half. Let me show you here. Remember that the sign belongs to the number it's in front of. The 1/2 is negative, not the 8. So I'm going to distribute a negative 1/2. And I'll get negative 1/2 times 2. Well, that'll be negative 1x. And negative 1/2 times 4, what's half of 4? 2. Nothing to do on the right-hand side yet. Looking at the left-hand side, I see some like terms. Do you see them? Do you see them? Mm-hmm. Well, you've got this 8 here and this negative 2. So I'm going to combine my like terms, and I will get negative 1x plus 6, and that's going to equal 3x plus 2. And then I will add x to both sides. And that will result in 6 equaling 4x plus 2. Now I have a two-step equation. I'll subtract 2 from each side. 4x will equal 4, and then I'll divide by 4 on both sides. That'll equal 1. And there we go. You want to check your answer. Plug 1 in here. 3 times 1, 3 plus 2 is 5. Plug it in here. I'm going to get 2 times 1, which is 2, plus 4 is 6. Half of 6 is 3. 8 minus 3, 5. And look at that, it checks. All right, that's your video for tonight, going over how to take care of the fractions. All right, Mr. Lawrence signing off. Have a good night, everybody.